All right, number one, we have function notation. Okay, the f of x is 2x plus 7. The g of x is x squared plus minus 3. They want us to take the two functions and subtract them. We were supposed to subtract g of x from f of x. So let's start with our f of x, which it happens to be 2x plus 7. And I'm going to subtract the entire g function. So I'm going to need parentheses, right? X squared minus 3. Okay, I need to distribute the minus sign here. So I have my 2x plus 7 minus x squared plus 3. Now I've got some, I only have the constants are my like terms, right? Plus 7 and the plus 3 I can combine. Okay. So now my final answer here, I'm going to put it in standard form. So I've got my minus x squared. Let's see, I've got a positive 2x, right? And then I have 7 plus 3, which is 10. Let's leave it just like that. We're good. Okay, now all these numbers to the right here, this DOK, it just it's the like the level of difficulty of the problem. The one in parentheses, that's how many points that this particular answer is worth. Just in case you were wondering about those. All right, number two. It looks like we got a composite function, right? So I'm going to start with the innermost function, and that's the g of 4. Okay, so I'm going to start with the g of 4, and the g function is x squared minus 3. So wherever there's an x, I'm going to put parentheses. Here I have x squared minus 3. Okay, and my x happens to be 4. Okay, 4 squared is 16 minus 3. 16 minus 3, 13. Then I'm going to take that 13, substitute it in there for the g of 4. So I have the f of, see the f there? F parenthesis, 13, which equals, now I'm going to go back to the f function. I have the 2 and times the x plus 7. And that 13, I'm going to stick right in that parentheses there. Then just solve it. 2 times 13 plus 7. That's it. That's my answer. Okay, number 3 is transformations. Okay. Now, we did transformations and we applied it to all kinds of different functions, right? But the concept's still the same. Inside the mathematical symbol, so I have parentheses here, I go left or right, and it's always opposite the sign, right? And what I mean by that, you would think that this would go left one, but we have to do the opposite. So it's going to go right one. Outside the mathematical symbol, it's going to go up or down, and it's going to follow the sign. So here I have a -6, so it's going to go down 6. All right, number 4. I'm going to try not to get off track like I did last hour. In a country with a desire to be more green, there's so many ways to get off track on this problem. Gas prices are rising exponentially at a rate of 28.4%. And that's a lie because it's 43%. Okay. If the average gallon of gas cost $2.70 in 2019, and this growth continues, create a function that models the exponential growth of gas prices starting in 2019. Use y equals a times the quantity 1 plus or minus r raised to the t. Now, the rate is always easy to find, isn't it? Because it's percent. It's our rate. Oh, that's right. Your screen gets cut off. Okay, that's our rate. We like to put it in decimal form so we can compute with it, right? Move the decimal places to 0.284. Okay, so I know my rate. This is going to be, it's rising, so it's going to be a plus. My rate, 0.284. If the average gallon costs $2.70, so there's my initial starting money, right? $2.70. That's my A. A right there. All right. Let's see. It starts in 2019, but they don't tell us what the date is right now. So that means they don't give us the time. So we need to find. Sorry. We're just going to put a variable for time, and they use t. Now remember, in our calculator, we got to use the x key. All right. Then they say, well, what would the price of gallon of gas be in 2024? Well, we're going to have to subtract 2019 from 2024 to get our t. So I'm going to. They want us to know in 2024. Yeah, it's 5 years, right? So here, my t equals 5. So I'm just going to substitute in that 5 for t. That 270 times, well, the 1 plus 0.2, I can add that. That's easy. 1.284, right? And my t is 5. Put that in your handy dandy calculators. All right. So I'm going to take 2.70 times 1.284, and I'm going to raise it to the 5.
Oh, you forgot to add.
Oh, it's the same thing. If I take 1 plus 0.284, I'm going to get 1.284. You can put a plus sign in there if you want. So that's going to be $9.42 in 2024.
2043.
No, it would be 42 because the number after it is 2. Which could happen, right? The way things are going. I can't imagine paying $10 a gallon. You think it'd be higher? I don't know. You guys let me know in 2 years because
How much does refilling your bike cost?
I filled it up Saturday. It cost me almost $18.
Almost
It,
18.
almost $18. Yeah.
Was it empty? Like near empty?
I don't know, quarter tank or so.
It's not that bad.
No, and I've been riding it for a long time. Gets great gas mileage, better than my Durango. I think it's. I swear, I'd be lucky if it gets 10. Number 5. Find the domain and ranges of this function. Okay, so I'm going to go ahead and just graph that function just to see what it looks like. Okay, so I got 2 raised to the x plus 4. Going to graph it, and it's a growth function, right?
My graph came out different. Is it because I'm using.
Oh, did I? Yeah, that's not right. Oh, see, I was up at mine. I never got out of mine. There we go. Yeah, I put the 4 in the exponent. Okay, so there's what my function looks like. Now, they want us to find the range. I'm just going to make a little sketch over here. So here's my function. Let's see. Looks like it's trying to get to the 4, right? The y equal 4. All right. So I'm going to look at my y values here. So on my y-axis, this is going to be negative infinity, right? It's going to be positive infinity. And actually, it's going to start at these 2 values for my x, right? Because it's going to keep going on here forever and ever. So my domain is negative infinity, positive infinity. And remember, infinities always get parentheses. Now, range is a little tricky. I know it's going to go up here to positive infinity, but I'm not really quite sure where it's starting.
So look at the graph.
I would I would probably go to my chart. Yeah, second graph, and notice that it's trying to get to that 4, right? And that and your calculator gets to a point in your calculator where, hey, I can't get any smaller, so I'm just going to say it's 4. We're going to use that 4, but we're not going to include that 4, so it's going to get a parenthesis. That y equal 4 line, that's acting like an asymptote, right? A horizontal asymptote. All right, number 6. I'm going to do the same thing. They want us to look at the end behavior, though, right? So when we look at end behavior, we want to look when x goes to the left or negative infinity, and x goes to the right or positive infinity. So let's go ahead and put that function in. So I've got 2 times 3 divided by 4 raised to the x. I'm going to graph that. And I know that it's going to be a decay problem because my b is a fraction in between 0 and 1. Okay. So again, let's look at the end of this behavior. As x goes to the left, so as my x goes to the left, what's happening to my y here?
It's going
Uh,
to
it,
positively.
it gets bigger, right? My x is getting smaller. It's going towards negative infinity, but my y is getting bigger. Okay, so the y is going to infinity.
And the x is going to negative.
Yeah, this time when the x gets bigger, goes to positive infinity, what's happening to my y?
Negative.
Well, be careful. Doesn't quite cross that x-axis, does it? In fact, if I go look at my table again, see if I'm going to the right, so I want my x to be bigger, bigger, and bigger as it's going to the right. It looks like it's trying to reach. It's getting smaller, 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 smaller. What's it trying to get to?
0.
0, right?
I'm so very confused on this one.
It is, and again, it's probably better. I don't know. I like drawing the graph out. Here's my y-axis. Here's my x-axis. And let's see, I've got this thing going like this, and it tries. Okay, and I'm looking at the ends, right? As x, this is negative infinity, positive infinity. As my x goes to, I'm looking at the end. So as my x goes to the left, what's happening to my y? It's going up, positive infinity. As my x gets bigger, so here I'm looking at this end behavior. As my x gets bigger, goes to the right, what's happening to my y? Well, it's trying to get to that y equals 0 line or the x-axis, right?
So very.
You're looking at the end behavior. Um, I don't know yet. I'm not sure. I'll let you know before class is over. All right, number 7. Okay, the price of a 57 Ford Thunderbird is modeled by the function below, where T represents years since 1957. So we're given all the information except the variable T, right? Time. Here, they want us to know. They want to know the value of the car in the year 2000, so we can figure out what T is, right?
Yeah, pretty easy.
Yeah, we could just take 2000 minus. Let's see, it starts in 1957, and that should leave us 43 years. So t equal 43.
So T worth around 27,366.64
Yes.
dollars.
Yes. If you put the 1,000 times 1.08 raised to the 43, you get the 27,366.
Are we doing this in degree mode or?
This is not going to matter. Okay. You don't have to worry about degree mode. The only time you have to do that is right triangle trick. All right, you guys are allowed to use your flow charts on the test. If you follow your flow charts, you have four terms, right? Four terms, you group. Group two of the terms and then group the other two of the terms. Okay, look at that first group. What can I take out? I can take out a 2. Anything else? Yeah, I can take out x squared. So 4x cubed divided by 2x squared is 2x minus 10x squared divided by 2x squared is just 5. All right, the second group. See, yeah, I can take out a factor of 3, and I'm left with 2x minus 5. And the whole idea here is to get these the same, right? Because that's one of our factors. The other factor comes from the other two values. 2x squared and positive 3. All right, number 9. Brianna was asked to show the complete factorization of the following polynomial, 3x cubed minus 75x. And she got 3x times the quantity x squared minus 25. Is this completely factored? Why? You got a 50-50 chance, right?
Because yes.
Yes. But what the team said.
What I like to do is I like to look at the problem that she came up with, 3x, x squared minus 25, and run it through my factoring flow chart. Can I take anything out? Nope. I'm just looking at the parentheses. I have two terms. Is it a difference of squares? Yes. It's actually x squared minus 5 squared. So I can factor that.
She's wrong.
Yeah, she is. So I can factor that to the base x plus the base 5, the base x minus the base 5.
Don't forget the 3x.
Don't forget the 3x. So that's my answer. Okay, number 10 is a multiplication and division problem. So I'm going to make this all fractions. I'll put that over 1. I'm going to go ahead and put parentheses around quantities. Then I'm going to look up here. Can I factor that?
Yeah.
Yeah. 4 is 2 squared x squared minus 3 squared. And we're back to the whole difference of squares things, right? So that equals 2x plus 3 and 2x minus 3. Now, I got to be careful here because I have a division symbol there, right? So I'm going to rewrite this whole problem. I got my x over x minus 4. I'm going to put parentheses there so I don't make a mistake. Times 2x plus 3 over 1. Again, parentheses. Dividing, I'm going to change to multiplication and flip this fraction. So in my numerator, I have the x minus 4 divided by my denominator. Factored denominator is 2x plus 3, 2x minus 3. Now I can go cancer culture on it, right? Cancel, 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 cancel. And I'm left with, let's see, I got an x on top and a 2x minus 3 on the bottom. Be careful, don't cancel out any more x's. Okay, error analysis. Describe and correct the error made, fix the mistake, and show the correct work on the right side. Okay. I'm just going to do it right up here. All right, we have addition, so that means we're going to need the LCM, right? Okay, in this, I'm going to go ahead and put parentheses around there. In this fraction, I need a x plus 3. And this fraction, I need an x. So I'm going to multiply this to both fractions, and that will eliminate my fractions, right? Okay. So the x plus 3's cancel, and I got to do the 4 times x, which is just 4x. This one, the x cancels, so I have to take the 2, there's a plus sign, 2 times the 2x, x plus 3. Getting ahead of myself. All right. So that is 4x, distribute the 2, plus 2x, plus 6. Combine my x's. 6x plus 6 is my answer. There's the correct answer. And what did she describe was what is the mistake that she made? Yeah, I don't see an LCM here, do you?
No, I'll see.
No LCM. Didn't multiply by the LCM. If you put no LCM, I'll get you. That's good enough for me. Did not multiply by LCM. Okay. Think you can do this tomorrow? Like I said, go home, take an extra blank sheet, do the problems all over again. Okay? To study at home, home work.
No, thank you.